Hopefully, everyone had a great opening day at CES. I enjoyed all the different exhibits, and I'm very happy to be here to talk about smarter machining, which we are using AI-driven digitization to help improve the throughput, quality, and cost of manufacturing. A little bit about me. I'm the Chief Innovation Officer at Mastercam. I have technology experience of over 20 years. I've spent most of the time with enterprise software with Fortune 500 companies, their global teams. And right now, my focus is with my knowledge to help lead AI and digital tech and data-driven solutions in the manufacturing world that can help improve the production and performance for all of manufacturing. So that's about me. About Mastercam, we are a CAM software company that we are one of the largest CAM vendors with over 450,000 seats worldwide. Since inception in 1983, we have slowly grown across all the different regions, and we are continuing to grow at a very high rate towards the world. We are part of Sandvik Digital Manufacturing, which Sandvik, just to give you everyone a little bit of a heads up, is a large engineering company. They have many different divisions, including mining, rock processing, machine tool development, and then the digital part of it. That's where we belong. And they have CAM, they have optimization and simulation software, metrology software. So we have a very broad portfolio as part of the Sandvik digital offering. So my agenda today, walk through what are the pain points in the manufacturing that can be solved using digitization and AI, what the landscape looks like, how is the digital adoption across the different industries, where AI application is. There's a lot of buzz around AI and starting to grow rapidly. So where are these use cases? How are we solving with Mastercam and Sandvik ecosystem? And then finally, how do we elevate the digital IQ so that we get to a place where we are using AI to its best avail possibility. So the current big pain points is the time around. So right now, manufacturing has been very efficient over the years, but now the expectation is faster turnaround while maintaining the high standards and making sure people are moving from large volumes to small volumes. So there's a lot of turnaround times are growing due to that, and due to volatility in the supply chain, etc. So there's a big push to make sure that the quality is maintained, but then the processes are really, really fast. The data silo is a big problem, right? There's a lot of good data. There's data that's been created over the years, a lot of expertise built into the data, but then the data lies with the customers, and they're baked into different, like your internal network drives, etc., and they're not tied together, right? Workforce gaps, right? Like as the senior experts are leaving the industry due to retirement and other reasons, there's not enough skills to fill those gaps and make sure that the manufacturing processes are kept going. And then finally, the cost pressures, right? There's a lot of demands for efficiency gains. Again, the geopolitical issues, and finally, there's a lot of push for sustainable production, which is putting pressure from local governments and other places. So where does the digital thread lie, right? So there is a big gap right now. So on if you look at the entire manufacturing life cycle, so it's kind of broken into three major regions, right? So one is the design and engineering, and this one has been fairly well digitized. There's use of PLM and ERP systems in this area where Most of the processes are well known and digitized, and they are tracked using various software, right? And then at the other end, the business systems, where this is where like your work is managed, you're planning the work across different machines, ordering systems, etc. So those are very well known and very well digitized, right, by most manufacturers. But somewhere in the middle, the manufacturing, that's when, like, once the part's designed and it's handed over either to the manufacturing department or to a tier one or a tier two manufacturer to actually fulfill the order, there's a lot of gaps. And it's in various increasing orders depending on the industry you go. In aerospace, there's a lot more scrutiny and there's more pressure to increase the digital thread. But then in other areas, we see many of the job shops, even big ones, where they have very little digital thread. They're doing things the way they were many decades ago, following manual processes, handing off paperwork in actual paper, right? So that's where we see the opportunity to kind of bridge the digital thread. And in Sandvik, with the properties that we have, it lends us naturally to this area to explore this opportunity and build this digital thread that kind of connects the entire manufacturing flow from start to the end, to metrology to testing. Apart from the digital push, this part, which was part of like Industry 4.0, now we have Industry 5.0, and that's led by AI. And AI has exploded, as you all know, in the last 5-7 years, right? So we've seen AI. You walk around, yes, there's not a single booth that doesn't have AI mentioned somewhere, right? So the adoption has grown fantastically, led by tech and software, obviously, and then financial, and then manufacturing. Although the adoption has grown and it's growing rapidly, we're still about less than 40% across the landscape, right? If you look at all of manufacturing, right? So there's, and even there's greater degree. There are certain processes where the AI has been adopted, but then there are many of the manufacturing areas which are not, fully leverage the AI uptake. So now we look at where AI is providing the big breaks or the big advantages to the manufacturers that have already starting to do, right? And we'll also kind of, I'll share where Mastercam along with Sandvik are starting to invest and solve some of these use cases. So the first one is the quoting part. This is the kind of at the leading edge when a new job comes in. Hey, what do you quote for this part? And what is the time needed? What is the material, etc. So there's a big gap here. Many of the customers that we have visited are using still a very traditional ways. They maybe have an Excel spreadsheet. There's only one person in the company that knows how to operate it. And if he's gone on vacation, the whole process comes to us, right? The other places we've seen, they have kind of like they do it kind of like in an ad hoc manner, or they have some kind of process that they go through and they make estimates. So quotes. So this is a very big area, and we are working with a couple of our partners, Up to Parts, Cloud NC, and ProShop, where they're starting to use AI and they're using the historic data to start to provide better estimation. It's not there where it's perfect, but then at least it solves this to a greater degree. So the new investment that we are seeing is being able to recognize all the features on the part and make sure that we can compute cycle times, we can compute the time it takes to do the entire process, and provide better quotes and time estimates. So part of it is the complexity. How can they investigate complex parts and then compare with what's been done historically, so they can get a good gauge of what that may look like. And then obviously we have to look into also the tolerances that are needed, right? So not every part requires the same level of tolerance and finishing. So all that has to be factored in to make sure that you get the best, most optimized quotes. So that works both for the person fulfilling the job as well as the person for the customer that's asking for a quote. The next one is the toolpath optimization. So this is a very big area for growth. We have invested a lot in Mastercam in developing a new technology called Everpath. This is a new tooling technology. It's going to be released very soon this year. Part of it is going to help us enable how do you compute the most optimal path using the geometry, right? So this will grow over time. It's not going to be perfect as it comes out, but over time we learn and we'll be able to better predict what kind of tool paths and make recommendations to users. So basically, the feature-based tool path is a great area of interest right now. A lot of companies are looking at how do they, with a CAD ingestion, how do they take that and make sure that they can break it out into features and break those features into generating the right tool path. And then also choosing the right tools. This is a very big time-consuming process, right? So every manufacturer has its specialty. They work with certain tool vendors, but then they may not be aware of certain tools that can lend them to greater efficiency. How do you make sure that they are aware that hey, the tools that you have can do the job in say 20 minutes, but if you buy these other tools, they can drop down your time by half, right? So those kind of recommendations will be very helpful to the user to make progress, right? The next one is machine availability. How do you make sure that, because the machine has a lot of variances, not the same machine across two different customers will be very different. How do you make sure that the tool path that you generated is configured right for the machines at hand? So that's another area that we are starting to look at. Obviously, tolerance and finishing is very important, and collision avoidance. So we got to make sure that when we generate the tool path, it is free of any kind of collisions and it's optimized to the best possible option. So we have a lot of different technologies that we're trying to bring in the Sandvik ecosystem, including the Vericut and Mastercam simulation to make sure that we can do it in the most efficient way. So in the upcoming R2 release of Mastercam coming up at the end of January, we will be offering a GPU-based simulation which is going to speed up the simulation by multiple X factors. So that will help offset a lot of the time taken to simulate. And then the machining part itself, right? So what happens on the shop floor? So once the part is the tool path is generated, the G code is generated, you pass it on to the shop floor machinists, and then how do you make sure that all the configurations that were considered while generating the tool path is what is there on the shop itself. So we got to make sure that you're checking for hey, the right tool is there, the right configuration is there. If not, make sure that you adjust for tools and etc. Automated tool measurements is a very big area, and that's where we have recently made an acquisition to a probing company. So we have Mastercam probing now as an offering. The probing makes sure that the tool starts out with the right measurements, right? And then you're not spending too much time changing and looking at different tools. A lot of time manufacturers have like, hey, after every 20 parts, check out all the tools and replace them. Whereas you can be optimal, you can actually program it in such a way that you're very optimized for when the tool requires a change. Right? And then also probing can help with making sure that if you have cast parts, they are adjusted and they are oriented well, so you avoid any damage down the process. So a lot of those things can be now automated and implemented. And then finally, the data analysis for predictive, like how we can capture data from the machine. So a lot of controllers have the various data that you can pull out using their APIs. How do you capture the data and make sure that you're using it for to optimize the whole process, right? So there's a lot of investigation and focus is going in. Quality control. So it's the final part of the whole manufacturing. How do you build in quality control? So a lot of the times, it's the departments are all separated out. So the quality department gets everything at the end, and they're just basically measuring and kind of saying, hey, does this meet the tolerance or not? But it's very smart to start doing tolerance and quality analysis as soon as the part's available, right? When it comes in the design phase, if we can send that out to the quality team and make sure that they can match and make sure that the right material is used, the tolerance that can be achieved within the given machines that they have, right? And then looking at data analytics and trending and kind of saying, hey, from your 20th part, we started seeing deviations because your tool started varying out more than what was recommended. So these kind of different analysis can be started if you start looking at this data and correlating with the machining process. And then how do you use computer-based, computer vision-based or laser-based evaluation inspections in process. So we have another company called Zero Touch, which is part of the Sandvik ecosystem, who offer laser measurements. So how can we combine those and make sure that as the part is being made, we can make sure that the tolerances are met and they are not going off step. And be proactive before. Finally, another key area where AI is going to help is via the co-pilot, right? As we saw some of the manufacturing pain points, one of the big points is how do you continuously train the user force, the workforce, the experts as they are going. They may hand over some information and some training to the new people, but then they got to keep growing with the product and the manufacturing process. And this is where we think our co-pilot comes in very handy, right? It can read the contextual information or user information versus and even a lot of the videos that we have created, the video libraries over time, and make that available based on the context to the users, so that they don't have to go searching for those. They don't have to ask other people and hey, how to do this thing. That information is available. The next use case that the Copilot solves is the voice control. It can control Mastercam, so you can perform simple to complex operations without having to find out in the menu where those operations are. Right? So you can talk to it in natural language. And then program control, you can change a lot of the speeds and different parameters by just conversing with the Copilot. Right? And then finally, setup assistance. So it knows certain steps have to be taken, so it kind of starts preceding those steps and providing the machine routes and operations out of the box, so that it helps the programmer move forward quickly. And over time, the Copilot will enhance its capabilities. Will be able to offer more voice-controlled programming and changes. We are also working with our Sandvik tool companies. We have a lot of tool companies called Sandvik, and they are providing us a wealth of data on what kind of tools and feeds and speeds and which tools to recommend. So we're going to integrate that into the Copilot as well. So that will provide further information and recommendation to the users who are performing the operations. So over time, we want to accelerate the workforce productivity and put Copilot assistance in the hands of the programmers. This is not AI to replace the workforce. This is AI to assist the workforce in being more productive. And we also are expanding our language support. So we have, apart from English, we have French, German, and more languages will be added on as well. So it will be available in more regions. So as these AI solutions are coming up and being enhanced, there are still a lot of challenges. I mean, data silos is a very big problem. So we trained our models using the data that we have provided. So it's very important that we provide we have a unified data storage where we can get customer data and we can manage that and help it to make the AI more intelligent or more aware of the user's need. Because each company, each user has its own way of performing. So we want to make sure that AI is customized to each user's need. So the data silos is a big challenge in that respect. Feedback loops, right? So A lot of the manufacturing processes we saw are very compartmentalized. So they have digitization to some degree, but they're all within the different functions. There's nothing that ties the whole process together. So because of this feedback loop, lack of feedback loops, AI is not able to help and find correlations. So this is something that we want to address. We want to make sure that we are not looking at each function separately, but how do we look at the different functions across the manufacturing landscape to help provide more insights to data. And then the cost, obviously, for small manufacturers, it is a big cost. So we are trying to make sure that we can provide a lot of out-of-the-box solutions. Right now, a lot of them are trying to do that, especially large enterprise. They have the bandwidth and the investment to go after and provide to make custom solutions. But then we want to make sure that we provide more out-of-the-box solutions for everyone to be helped. And then finally, how do you elevate the digital IQ, right? So as we looked at this before, how do you, the lack of that unified data layer, this is something that we are very actively working on. So how do you build that data layer across the different functions, right? And there's a lot of variability in this. This is not all of just Sandvik's property. Customers will have some of Sandvik's solutions and some third party. We got to make sure that we are aware and we are working towards a unified data solution that can cover across the span, and then use that data layer to start building the intelligent layer on top of it that can start understanding the correlations between the different pieces of data and then provide the necessary insights, right? And then look at patterns and opportunities that were not previously available, right? Because within an industry, if there are different departments with different tiers, like contract manufacturers, a lot of the data is lost between the different handshakes. So, and what will help us here is another new technology that's kind of starting to form up is agentic AI. So what this means is we can have different layers kind of understanding their use cases and information, and then coming together to kind of help each other, each of those agents to kind of form a network of agentic AIs that can help with provide greater learning and transfer, help to automate repetitive tasks. So we've got to start with what tasks makes most sense to automate, so those can be done. Help with machine learning, and then the AI agents start to collaborate and help form that layer of AI intelligence. Right? And then human starts to work as designers. So that's the evolution of. So right now they're doing the manual work of creating the programs, the machining, but then they start to evolve as designers of the system. So they use their expertise to help define what those correlations are and how we can use the data to solve some of the problems, and then establish the feedback loops which can further accelerate productivity and provide a more seamless process across the different industries. Right? So the future of manufacturing is intelligent, connected, but mostly important, human-centric. You want to make sure that the human is in the center making those decisions, and it's not something that is done without the human in the center. If you want to learn more, we are in the booth right around the corner where we can have deep dive demos if you're interested of Copilot and other technologies that we have. So thanks for listening in, and I'll open up for any questions.